Welcome to my channel Maths Ki Prerna. In this video, I am covering the topic triangle and its property from grade 7 CBSE. I'll be explaining the concept in a simple and concise manner and also will be covering few questions from the chapter. So let's get started. Let's start with the basics. What is a triangle? Triangle is a three-sided polygon. There are three sides, side AB, AC and BC, vertices A, B and C, and angle A, angle B and angle C. We can distinguish types of triangle on the basis of the sides. There are three types of triangles: equilateral, isosceles and scalene. Equilateral where all three sides are equal, isosceles where only two sides are equal, and scalene does not have any sides equal. On the basis of the angle, we can distinguish as right angle triangle where one angle is 90, obtuse angle triangle where one angle is more than 90, and acute angle triangle where all the angles are less than 90. So there is another key concept which is median and altitude. So let's take this triangle A, B and C. If we join a line segment from any of the vertices, so let's say A to the side opposite, but the midpoint of the side opposite. So this line segment is called a median. So line segment that joins the vertex of the triangle to the midpoint of the opposite side is called a median. And we can draw such two more medians from the other two vertices. They all join at a single point, which is known as centroid of the triangle. Altitude. So altitude is a perpendicular line segment from the vertex of a triangle to the opposite side. So from each vertices we can draw the perpendiculars on the opposite side, and these are known as altitudes. And they all meet at a single point called an orthocenter. We have already covered the interior angles. Now let's discuss exterior angles. So if we take a triangle and we extend its side, so the angle which is formed by extending the side and the other side is known as an exterior angle. So we can see this, there is angle 1, angle 2 and angle 3. These are all exterior angles. There are some important properties of the exterior angles. So if we see this is an exterior angle and there is an adjacent interior angle which is angle A, the sum of the exterior angle and the adjacent interior angle is 180 degree. And if we add all the exterior angles, so angle 1, angle 2 and angle 3, the sum is 360 degree. That takes us to a very important property which is known as exterior angle property of a triangle. Let's take this figure. Here we can see an exterior angle which is denoted by D, and there are two non-adjacent interior angles, angle B and angle A. So as per this property, the exterior angle is equal to the sum of the two non-adjacent interior angles. We can quickly prove this. So this is triangle PQR. I have extended QR and I have made a parallel line QR from R. So we understand PR and QR. Both are acting as a transversal on these two parallel lines. Now, this angle and this angle, these are alternate interior angles, and since these are parallel lines, these will be equal. So let's take this as angle A. This will be also angle A. We'll also understand this angle with the other angle. Now we understand these two will be the corresponding angles, and the corresponding angles in a parallel line are equal. So we can take this as B and this also as B. So the exterior angle here is A plus B, and the sum of the interior angles is A plus B. So which proves the exterior angle property of a triangle. There is another important property which is regarding the interior angles of the triangle. As per this property, the sum total of the three interior angles of a triangle is 180. So we can see this triangle, and in this A plus B plus C is 180. We can quickly prove this by below diagram. So we have this triangle as ABC. What we have done is we have extended the base BC and we have created a parallel line which is touching the vertex A. Now, since these two are parallel lines, so AB and AC are acting as transversals. So let's understand this more deeply. This angle will be equal to this angle, as these are alternate interior angles. Let's denote this by X. Let's take this as Y, and let's take this as Z. Now this Z angle will be equal to this one, as this is again the alternate interior angles. And X plus Y plus Z, which is this angle, which is right here, is obviously 180 degree. So that proves that the sum of the three interior angles of the triangle is 180 degree. Let's quickly go through some special triangles. So there's this equilateral triangle where all sides are equal, and we understand as per the angle sum property, the sum of the three angles is 180. So that means each angle in equilateral will be 60, 60 and 60. Isosceles triangles have two sides equal to each other, and so the angles opposite to the equal sides are also equal. There is a very important property with regards to the sides of a triangle. So if we add two sides, let's take side AB and side BC. If we add both of these, the result will be more than AC. So AC will be smaller than the length of any two sides. So that means AB plus AC will be greater than BC, and AC plus BC will be greater than AB. There is also something with regards to the difference between the length of any two sides. So if we minus the length of any two sides, it will be always less than the third side. So we can denote this by these statements, which is AC minus BC will be lesser than AB, AC minus AB will be lesser than BC, and so on and so forth. This takes us to the last part of this chapter, which is the right angle triangle, a very special triangle. Um, this is a right angle triangle. We did discuss that one of the angles is 90 degree. Now the side which is opposite this 90 degree is known as hypotenuse, and this is the longest side. And the other two sides are called legs. For the ease of the writing, it is also mentioned as height and the base. Now there is a very important theorem which is based on the right angle triangle. It was named after a Greek philosopher, Pythagoras. So as per Pythagoras theorem, the square of the hypotenuse side, so we can take this triangle. the hypotenuse C is equal to the square of the two other side. So that is a square plus b square is equal to c square. And this is an important theorem which we will be using extensively in the future chapters as well. So we've done a lot of theory, lot of concepts. Let's do a few questions. Okay. So this is a question diagram where we have to find the value of x. Now, so understand this angle 110 is basically the exterior angle. And as per the exterior angle property, we know it is equal to the sum of two non-adjacent interior angles. So let's write this exterior angle is equal to sum of non-adjacent interior angles. So here we can easily write 50 plus x will be equal to 110. And if we solve this, we will get the answer as 60 degrees. So through the exterior angle property, we were able to determine the value of x. So on the same concept, we have few more questions here. We have to find the value of x's in each of these figures. Now in the first figure, it's very easy. X is nothing but your exterior angle. So very simple. X will be equal to 30 plus 40, which is nothing but 70 degrees. In the second figure, exterior angle is 80. So 80 is equal to the sum of these two non-adjacent interior angles. So we can write x plus 30 will be equal to 80. So x will be 80 minus 30, which is nothing but 50 degrees. And the third figure, exterior angle is 125, interior angle is x, and this is a 90-degree angle. It's a right angle triangle. So we will write x plus 90 is equal to 125. That gives us the value 125 minus 90, and that's nothing but 35 degrees. So to the exterior angle property, we have found the solution for all the x's here. Okay, now here we have to find the value of x as well as y. So we will be using more concepts here. So let's first do this question, which is part 1. Now here we can see this is the exterior angle and this is the adjoining interior angle. The sum of these two will be 180. So y plus 120 is equal to 180. So y will be equal to 180 minus 120, which is nothing but 60 degrees. So we have the answer for y. Now we have to find x. Now x is non-adjoining interior angle and 50 is also non-adjoining interior angles. And we know the exterior angle is sum of these two. So we can write 50 plus x will be equal to 120. So 120 minus 50 will give you the answer as 70 degrees. So x is 70 degrees. In the second figure, now we have to find x and y. Can we find a relationship between y and the other angle, 80? Yeah. So these are vertically opposite angles. So simply we can write y is equal to 80 degrees. Now we have y, we have 50, and we have to find x. So we know the sum of the interior angles of a triangle is equal to 180 degree. So that means 50 plus 80 plus x is equal to 180. So x is equal to 180 minus 80 minus 50, which is 50 degrees. So the value of x is 50 degrees. Okay, and let's do the third part of the question. We have to find x and y. So x is the exterior angle and y is the adjoining interior angle. Now, exterior angles, we know it is equal to the sum of non-adjoining interior angles. So x will be equal to 50 plus 60, which is 110 degrees. So x is equal to 110 degrees. And we have to find y here. So we can find that x plus y is 180. So y will be equal to 180 minus x, which is 110. So y will be equal to 70 degrees. So we were easily able to find the value of x as well as y by using multiple properties. Now, this is a question where we say the ABC is a triangle, it is right angle at C, and AB is 25, AC is 7, and we have to find the value of BC. Okay, so this is a right angle triangle, so we can easily use the Pythagoras theorem. So let's write the Pythagoras theorem. So as per Pythagoras theorem, AB square will be equal to AC square plus BC square. AB square is 25 square, AC square is 7 square, and BC we don't know, so we'll keep it like that. So BC square will be equal to 25 square. We know that as 625, and 7 square, which is 49. So BC will be equal to 576, square root of 576, which is nothing but 24. So BC is 24 centimeter. So through Pythagoras theorem, we were able to find the length of BC. This is going to be the last question which we are solving here. So we have to find the perimeter of a rectangle, not triangle, whose length is 40 centimeter and diagonal is 41 centimeter. And we have to find the perimeter. To find the perimeter, we need both the sides. So we know one side, we don't know the other side. So let's assume the side as B, okay, which is the breadth. So we can easily write 41 square is equal to 40 square plus B square, which is B square will be equal to 41 square minus 40 square, and 41 square is 1681 and 40 square is 1600, which gives us the value as 81. So that means B will be equal to square root of 81, which is 9 centimeter. So we found the value of B, which is the breadth. Now, how do we find the perimeter? So perimeter is to L plus B for the rectangle. We already know the length, which is 40, and we have just find out the breadth, which is 9, so which is 2 into 49, which is 98 centimeter. So with the help of the Pythagoras theorem and the formula for the perimeter, we are able to find the perimeter for the rectangles. So with this question, I have covered all critical topics from the chapter and also solved a few questions. So to find the solution of other questions from the chapters, please do watch other videos. Thank you so much.